In this video, we're going to be looking at parallel lines and perpendicular lines. For parallel lines, the important thing to know is that they have the same gradient. That's the only thing that we can look at when we're looking at lines given in a form, say y equals mx plus b. If the m is the same, then that means that they're parallel. Lines are perpendicular now there's two conditions that we can determine if they're perpendicular. The first condition is that the gradient of the first line times the gradient of the second line equals -1, or if the gradient of the second line is equal to the negative reciprocal of the first gradient. So the way we can do that is we can say that m2 equals -1 over m1. To get a better idea of how this works, we're going to do an example. So the first example we're going to look at is deciding if lines are parallel or perpendicular, or possibly neither. They could intersect in a different way. So here we're going to decide if the graph of each pair are parallel, perpendicular, or neither. So the first one, we've given y equals 1/2 times x plus 2, and 2y minus x equals 5. So the first thing we need to do is make sure that they are both in the same form, and the form that we want is y equals mx plus b. If it's not in that form, it's hard to determine the gradient. So this is the best way we can find that. So the first one, we've been given that and it's in the right form, so we'll just copy that down. The second one isn't in the correct form, so we're going to have to manipulate it a bit. I'm going to start off by rewriting it. So 2y minus x equals 5. And then over here, I'm going to write in brackets what I'm doing to the equation, just so we can keep track of what's going on. I want to get just y on its own. So the first step I'm going to do is get rid of this x. So I'm going to add x to both sides. When I do that, we're going to have on the left side 2y equals 5 plus x. Next, I want to get rid of this 2. Now, this is like saying 2 times y, so I'm going to divide the whole equation by 2. So when I do that, I'm going to have just y is equal to 5 on 2 plus x on 2. Okay, so we've divided everything by 2. I'm going to neaten this up so it just looks a bit neater. Okay, so we're going to have y equals, now I want x to be the first thing, but I want to have a number then x. So when we've got x on 2, that's the same as saying 1/2 times x. That's the same. They're the same, just written a bit differently. And then I'm going to put 5 on 2 next. I've only changed the order and the way this looks. It's the exact same equation. Now that we have them in the form of y equals mx plus b, there's our 2 there, we can see that the m for this one is 1/2, and that the m for this one is also 1/2. Looking at the number in front of the x here. As they're the same, that means that they are parallel. Okay. Next, we're going to answer B. It's going to be the same process. Okay. So the first thing is identify if they're in the right form. We can see here that y equals etc. and y equals etc. It works. They're both starting with y and then have the rest. So that's good. I'm going to rewrite them just so we can have our working space here. Okay, now because they're in the y equals m x plus b, and then the same for this one, as they're in the same form, we can identify that the gradient for this one is -3, and the gradient for this one is 1/3. Now, we know that they're definitely not parallel, so let's test to see if they are perpendicular. Now, we said before that if they're perpendicular, then they will meet one or both of these. In fact, they should meet both, but we will just use one. Because we've been given both gradients, I'm going to use this one. So if we make this m1 and this m2, we can multiply them and see if we get -1. So our m1 times m2 should equal -1. So our m1 is going to be -3, and our m2 is 1/3. I'm going to pop that in my calculator just to be safe. So we've got -3 times 1/3 gives us -1. And that's true. And because it's true, then those two lines are perpendicular. Okay, now the last one, I'm going to use this space over here. For C, once again, we need to make sure that they're in the same form. So first of all, we need to just copy things down. So we're going to copy down the first one, and whilst I'm here, I'm going to copy down the second one as well. Okay, now we need it to be in the form y equals mx plus b, just like over here. So we'll start off with this one. We want y's to be the only thing on the left hand side, so the first thing I'm going to do is take away that 3x. When I do that, we're going to have 2y is equal to negative 3x minus 5. Now I've skipped straight to putting it on the left side because that's where we want it. Over here we took the extra step to switch them around. Okay, so I've put the negative 3 in front of the negative 5, and now we want to get rid of this 2, so we're going to divide by 2 because it's 2 times y, so we do the opposite of that. So we're left with just y is equal to, we have to divide everything by 2. We have y is equal to negative 3 on 2x minus 5 on 2. And we're done. So that's in the y equals mx plus b form. So that's good. And we're going to do the same thing for this. So we need to get rid of the x, so it's just going to be y on its own. So if we take x away, because it's a positive x, we're going to have negative y is equal to minus x plus 2, because that was a positive 2 to begin with. And we just need to change all the signs, because we can see here it's a negative y, so we could say this is a negative 1y. So if I divide everything by negative 1, we're going to have a positive y at the end. When we divide or times by negative 1, we're just going to change all the signs for everything in the equation. So we're going to have a positive y, a positive x, and a negative 2. Okay, so now that we've done that, we can see that they're definitely not parallel, because this is a gradient of 1, and this is a gradient of negative 3 on 2. And now I'm going to make this 1, make this 2. We're going to multiply them and see if we get negative 1, and if we do, they're perpendicular. So first we're going to have m1 times m2 equals negative 1, just writing down the formulas. And our m1 is negative 3 on 2 times our m2, which is just 1. Now we don't need a calculator for this because we're just going to be doing negative 3 on 2 times 1. That's going to equal negative 3 on 2. So that means that it's not perpendicular. So in the case of this question, parallel, perpendicular, or neither, this one is neither. Okay, so that's how we use these formulas to determine if they're perpendicular, or just looking to see if the gradients are the same to determine if they're parallel. The final example we're going to do is finding the equation of a parallel line. Okay, so when we're working with these, we need to look at, first of all, the question, find the equation of the line that is parallel to y equals negative 2x minus 7 and passes through 1, 9. Okay, so for A, we can see that we want to have an equation of a line. So equation of a line, we're going to stick with y equals mx plus b. Okay, and we know that it needs to be parallel to this line. So for this line, we can say that m is minus 2. So for our equation, we need to make sure that the gradient is negative 2. So that means that we know that y equals negative 2x. Okay, but we still don't know what the b is. And the reason why is because it needs to pass through 1, 9. Now, we could just, if it just said find an equation that's parallel to this line, we could just say this, because y equals minus 2x is a line that's parallel because they have the same gradient. But the problem is that if it needs to pass through this, we need to know what that number is. And it may be 0, but it may not be 0. Okay? So the way this works is we need to sub in 1, 9 into this equation. So we know that this is our x value and this is our y value. So whenever we see x, we're going to pop in 1, and whenever we see y, we're going to pop in 9. So we're going to have 9 is equal to minus 2, and then instead of x, we're going to have 1. I'm going to pop it in brackets because it's being multiplied, plus b. So we know that 9 is equal to minus 2 times 1. Minus 2 times 1 is going to be minus 2 plus b. Now we can just solve this. So we want to get rid of that minus 2, so we're going to add 2 to both sides. So we're going to have 11 is equal to b. So the line that we're going to have that is parallel to y equals minus 2x minus 7 that passes through 1, 9 will be y equals minus 2x plus 11. Okay, so that's our answer for A. We're going to use something similar for B, but because we're finding a line that's perpendicular, we're going to have to go through a couple more steps. Okay, so the first thing we're going to do is we're going to rewrite this equation. Y equals 3 on 4x minus 1. Now we only care about the gradient, so we know that the m is 3 on 4. But we need to find a perpendicular gradient, okay? So we can't just go straight into the step of substituting in this point. We need to find a line that's perpendicular. So we can use the other equation from before, which was this. I'll write it up here. m2 is equal to minus 1 over m1. So that was the negative reciprocal. Now, we could do it this way, but we know that whenever we're finding the reciprocal of a number, we just need to switch the top and the bottom of the fraction. And if it's a negative, we just have to make it a negative. So the perpendicular gradient to this will be a negative 4 on 3. Okay, so you could use this method. It's good for if you've got a whole number, but if you don't have a whole number, just switching these is good enough with a negative. So we know that this was our m1, this is our m2. Okay, so we're going to use this gradient, as that gradient is perpendicular to this one. So y is equal to negative 4 on 3 x plus b, for the exact same reasons that this one was plus b. Okay, so as that's the case, we need to sub in our point. So our point from the question is 3, negative 2. So wherever we see an x, we're going to pop a 3, and y, we're going to pop in negative 2. So we'll do that now. We're going to have negative 2 is equal to negative 4 on 3, and then in brackets I'm going to pop 3 plus b. Now you can type this into the calculator if you want to, and generally speaking, that's probably a safer bet because you may not be as comfortable working with fractions, but you'll find the answer of negative 4 on 3 times 3, or as written here, 3 in brackets, we're going to get the answer of negative 4, and the reason why is because we've got 3 times something divided by 3, so they would just cancel out. So if you want to go that extra step further, you can see why that's the case. But if you're unsure about how that works, just type it in the calculator. There's nothing to worry about there. So minus 2 is equal to negative 4 plus b. Now we just want to get rid of that negative 4. So I'm going to add 4 to both sides because that was a negative. We're going to add it. So minus 2 plus 4, it's going to be positive 2, is equal to b. So now we can pop that back into our equation up here. So y is going to be equal to negative 4 on 3x plus 2. And that's our answer for the perpendicular. That was our answer for the parallel. And you can see when you're given an equation of a line and a point, you can have something that's both parallel or perpendicular depending on what you need to do.